have one participant in the class and others are names. And I'm going to talk to names. Yes. Thank you.
I have notes.
You guys are like like film stars. Huh? You don't give photos to everybody. It's good to see. I mean, you at least in online, if you can see each other, I'll also remember you. You know that the students I remember the most, especially in online classes, are the ones with whom I have interacted and who have a face that I see. So I see that, oh, this is how Ishan looks like. Oh, this is how Ritin looks like. So now I'll be able to connect more because always the face comes first. You may forget or if the face is not there. Like, thank you for putting your videos on. So let's get going. All right. So this is where we were, and we want to quickly. Oops, sorry. We want to quickly wrap up with Matra Vrittas, and we'll get into the math and music part, right? So these were the rules for Matra Vrittas, and as we saw, I mean, of course, we did not see 1, 2, 3, and all, but if you look at it, this is one Matra Prastara, there is one possibility. Two, there are two. Three, there are three. Four, there are five, and five, there are 8, right? And we also saw in the last class that if you cut this part, if you cut and paste it, right? So this is that part, right? This is that design, and the earlier this part is the earlier case, this one, right? The 3 Mata Prasthana. So we copy and paste, and you have all gurus here, all lagus here. This is something that we had seen. So we have seen Prastara. So the next question is, what is the Sankhya, right? What will be the count? And what's the way to arrive at that number? So Sankhya is the count as well as the way in which, or the method in which we can arrive at that particular number. So if you want to find S of n, as in the Sankhya of n Matra Prastara, what do we need to do? Anybody? Just do a raise hand and I'll call out your name. If I want to find how many such numbers are there, or what is the count, how many possibilities exist for n Matra Prastara, how do we find? Just do a raise hand.
The sum of the first 10.
Raise hand.
No, I was asking.
Yeah, what's the question?
Sum of the first 10.
No. Sn is not sum. S stands for Sankhya. You don't want to take, let's say, f of n. If you want, that's your favorite. So f of n, that is the number of possibilities for when you have n Matra Prastara. Oh, this you are familiar with. Huh? Okay. Akshat?
I guess we add the previous two to get the next one.
Right. So this will be f of n minus 1 plus f of n minus 2, right? So if you want to write in terms of Sn, it will be S n minus 1 plus S n minus 2, right? All right. Okay. Let's move on. So this is how we find the Sankhya, right? All right. And that is the sutra that is given here in Vritta Jata Samachaya. Remember all these things. Who is giving us all these things? Name of the person with respect to Matra Vritta, Matra Prastara. It is Virahanka. Okay. The earlier one was Pingala, what we saw in the earlier sessions. About Matra Vritta, we are getting it from Virahanka. All right. Therefore, yeah, so we get the following sequence. So this is how Virahanka arrived at what we call as the Fibonacci sequence. And if you have heard of the story of Fibonacci, You might have heard that he was observing some way of, progeny of rabbits. And then he came up with this kind of pattern. And maybe he saw this pattern in nature. But for Virahanka, the motivation was poetry and music. So that's how he arrives at this pattern. About 5 centuries before Fibonacci's time was Virahanka's time. Fibonacci is 1200 Common Era. And then he comes up with this Uddishta process, right? So once we know the Prastara, once we know Sankhya, we have 2 more things. One is Uddishta and Nashta. So what is the Uddishta? Uddishta is given a Mauric meter form, or matra sequence, right? How do we find which row does it come, right? That is Uddishta. You are given a particular form. So if you have something like G, L, G, G, you want to find this will be in which row. And there is a particular procedure given. So this procedure, you can read it up. We'll take an example to understand, just in the interest of time. Suppose you want to find Guru Laghu. This will come in which row number? Of course, it is a 6 matra prastara. Can somebody tell me, how do I know that it is a 6 matra prastara? And not 7, not 5, Shresht?
Yeah, because like the G and L's are 1 and 2, so then you can just add that, right?
Right. So Guru is 2 and Laghu is 1. You add them up, you get 6.
Yeah.
Right. So that is why it is 6 matra prastara. So what we do is we write down Guru Laghu like this. Wherever you see a Guru, above and below, you write the numbers. And when you have a Laghu, you write the number just above that. But what numbers? We write the Virahanka sequence, or the so-called Fibonacci sequence. But in Fibonacci sequence, you have an extra 1 at the beginning, right? It is 1, 1, 2, 3, 5, 8, 13, 21, and so on, right? And those of you who are new to this, if you look at it, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13. So that's what we were talking about. If you want to find the nth term, you need to add the previous 2 terms. So we should have this sequence, and then what we will do is we will start, you see, 1, 2, 3, 5, 8, 13. So if you are having a GGLL, what will you do? You will do 1, 2, 3, 5, 8, 13. Okay, if you have a LLGGLG, what will we do? Again, this will be 1, 2, 3, 5, 8, 13, 21, 34, 55. Here the count is more, so it will go further. So we need to write it in this way. That is step number 1. What we do next is, what is the largest number in this? The largest number is 13. So we write 13. From 13, we subtract the numbers that appear above the gurus. The numbers that appear above the gurus are 1 and 5. Add them up and you subtract from 13. So you get 7. Right? Now, if you list 6 matra prastara, do you have that list of 6 matra prastara? You should, right?
Yes, sir.
So does it match? Is the 7th row Guru Laghu?
Yeah. Yes.
We can check. G G L L G G L L L G G L L L G L L G G L L G L G. Right? 1, 2, 3, 4, 5, 6, 7. This is the 7th row. Kirti?
So why do you choose 1 and 5, sir, instead of 1 and 3 or 3 and 5?
Right. So the algorithm says that the numbers written above Guru have to be chosen.
Okay, sir.
That's what the algorithm states. Of course, the next natural questions would be, what questions come to your mind?
How does it work?
How does it work?
Why does it work? How
How-
did
How did they
Hankati
arrive
got
at it?
Right? How does it work, or why does it work? How did he arrive at it? How did he arrive at it? Because this is not as simple as the earlier one. The earlier one, Guru and Lagu, you convert it into binary, you make some observations, you already know certain things in binary numbers, you are kind of, you will get there, of course. I'm saying as if it is nothing, that itself is a great observation. But what I'm trying to say is that this one is even harder to observe, right? Kanish?
So why are the numbers below the gurus?
Sorry, say that again.
So why are the two numbers below the gurus?
Because we need to use this sequence 1, 2, 3, 5, 8, 13, 21. So if you look at it, what we are doing is we are using only 1 and 5, and remaining numbers we are not even using. But unless and until we write it in this sequence, how do we know which numbers will come above the gurus? If you look at the last example, see this 1, 2, 5, 13, 21, 55 are all not required. We are concerned with these three numbers. So those three numbers give us the result. But how do we know which numbers will come there? We'll have to write it in this order.
So, but does it have something to do with the value of guru, which is 2?
Yes, so even I was thinking that because G is 2 and L is 1 in like the value. So is it because of that we are writing two numbers for G and just one number for L, so that you get some sort of pattern? And I'm not sure why exactly we're just taking the above number of G. I'm not sure exactly, but I guess the weightage has something to do with it.
So these are very good points. Could be there might be amazing ideas hidden in this. But I think we'll get some more insights, some more, not a lot more, some more, when we look at the Nashta process. Because Nashta is going to be the opposite of Uddishta. Anushka?
This is actually related to Matra Prastara, but the method that we followed earlier. So we were thinking about binary, but then when they had arrived at all this, did they know binary or did they do something else?
So what exactly do you mean by did they know binary?
No, I mean, we have got knowledge about how binary and computers work, how we convert from binary to decimal and all that stuff. But did they have all those, at that time was all this discovered and something like that?
Right. So let me ask this question. When you saw this question of coin toss problems for the first time, heads and tails, did you know about binary? You did not know about binary, I presume, or you knew already?
I mean, when we were very small, like when we first introduced, then we might have known.
Not known. So if somebody says that, okay, there is a family, there are two siblings in that family, two children, both can be boys, both can be girls, the elder can be boy, the younger can be a girl, the elder can be a girl, younger is a boy. We know that these are the only 4 possible outcomes, of course, if you are not considering other genders. These things we know without being taught binary, right? We know this thing. So in some sense, we have some knowledge about binary, but we are not able to apply that into other things. We cannot say that, okay, somebody knows these 4, they'll start doing binary math, right? What we can see here is that they have used these ideas, what we call as binary mathematics today, or they should have known these things. Otherwise, how can they devise all these algorithms? Is what you will see when you replace all the gurus with 0 and lagus with 1 in that original Pingala's idea. And you will see how beautifully binary mathematics is integrated over there. So if they did not know that idea, I'm not saying you think only in terms of zeros and ones, but they had that idea and they could manipulate that. So that idea or that notion of binary mathematics existed. If I want to give another example, let us say decimal place value system. Now, decimal place value system, it is believed that it came into existence from Pingala's time to Aryabhatta's time, that is 300 BCE to 500 CE. But even before that, we see appearances of names of numbers like Dasha, Sahasra, Shataka, all these. Even in earlier texts, even in Ramana, we see these numbers, powers of 10 and all that. Now, does that mean that they knew decimal place value system then? We cannot say that, because decimal place value system involves a lot of other things. I mean, you can name anything as 10. 10 is just a name, right? It does not mean 1 0. It's just a name given to a particular count. But they definitely had some notion of the base 10 system. Similarly, in binary, they had a notion of binary mathematics, and they were also able to use that in place value system, which is what we see in this Guru and Laghu thing. So these two things are clearly evident in their work. Now, it would be too much to say that they were thinking about computer science, because computers never existed at that time. But the math that is required for computer science, to a great extent, they were exploring. It's just that the motivation was not computers, it was music, poetry.
Yes, sir. That answers the question.
Okay. So let's move ahead. Yeah. So this is where we are. Now, these two questions, these two questions are open. We still need to think about, why does this work? How did he arrive at this? Okay. Let's look at Nashta process. The procedure is explained here just in case anybody wants to refer back to the presentation later on. But let's take an example and see. So here we want to find the 7th metrical form of 6 Matra Prastha. Arushi, question or comment?
Sir, comment on why I think we write those 2 numbers for G and only 1 for L. So can you go to that slide? If you see all of the numbers of like there are in the Prastara, there are 5 Gs and then there are 8 Ls. So there are those 5 plus another 3. So does that have any connection?
5 and 8. So, but how is that related to why we use the numbers only above gurus?
Like the number of the total number of numbers that we use. No. Okay, that won't work. No, sorry.
Okay, no problem. Right. So Nashta is something like this. Now we are trying to find what will be the 7th metrical form in a 6 Matra Prastara. Right. So what you do is you write down 6 Ls, 6 lagus. On top of it, you write 1, 2, 3, 5, 8, 13. Simple. Step number 1. Step number 2. The last number is 13. Okay. What is the metrical form that you want to find? You want to find the 7th metrical form. So you subtract 7 from 13 and you get 6. From 6, you subtract the highest number possible in this. Clearly, that highest number is 5. And you get 1 as the result. From that 1, you subtract the highest number possible in this list. Clearly, that number is 1. So 1 minus 1, you get 0. You think which are the numbers that you subtracted? You subtracted 1 and 5. I mark them in bold, those L's. Those L's, along with their successors, you combine and you make them a G. This is all magic, okay? And then you leave the L's in between. So you get GL, which has to be the 7th metrical form. Okay, Advait.
Yes, sir. Can you please once again how that subtraction took place?
Right. So let me take another example. Let's say that we are dealing with 6 metrical form. Okay, so this is 6 matra prastara. And you pick a number. Which row number you want to find, Advait?
8th row.
8th row. So you write 1, 2, 3, 5, 8, 13. Now you subtract 8 from 13 because you want to find the 8th row. What is left is 5. Now you look at this, you subtract the greatest number possible from 5. That is 5. Now you have a 0. The procedure ends when you get 0. Now you make this thing bold. And you combine that bold L with the successor. And that becomes a G. The rest of the things remain L. The question is this the 8th row?
It is, sir.
It is.
Sir, why do we subtract 7 from 13 and 13 minus 7 is the first?
7 is the row number that we want to find. Okay. Okay, some interesting comments in the chat. This is crazy. I know. Now, okay. On top of it, no motivation. Anushka, how dare you make that statement? What no motivation? Huh?
So
What-
they never explained how they got the result. If they probably gave us the method, then we could use it for so many other stuff. But they never explained it. They just gave the.
Right. So the question is, why did they not explain? So let's see how it is written in the text. It is written in verses form. Okay. And in those days, texts were not, voluminous books that we have today. The material that they were using to write texts were all palm leaves, bark of trees, and everything. To store was difficult. To carry was difficult. I don't know how many of you have actually held a manuscript in your hand, palm leaves
Yes, I have.
manuscripts and all. The actual length of many palm leaf manuscripts, would be actual length. I'm not, this is the actual size. In this much, they write 8 lines, 10 lines sometimes in this much width. So brevity was something that they had to ensure because you have to keep it, the letters definitely has to be small. And in fact, there is a lot to manuscriptology here, depending on the material that you have. For example, why do you think most of South Indian languages have letters which are, circular in shape, so to say, versus Devanagari, which is more to do with vertical lines? It depends. Have you ever thought about that? I never thought about it unless, until I heard it from an expert who was into manuscripts. Yes, Kirti?
No, sir. The things they used to write were different, so they modified the script.
The material.
Yes, sir.
The material on which they were writing were different. So if you write like this on a palm leaf manuscript, it will tear.
In South India, it was mostly palm leaves, and in North India, it was mainly wood.
Right. So depending on that, the script changed, how the script evolved. So there is a lot of things that goes behind what we see superficially as mathematics. How it is presented, why only certain things were presented. And it's not that proofs were not discussed, proofs were discussed, but it was discussed in the class. And we need to think for whom this material is written. If this material is written for people who are into music, Why would they care about proofs? They would care about music part. Why are you torturing us with proofs? Right? It is we who are interested in finding proofs in that. We cannot expect proofs at the wrong place. So all those things are there. But proofs were present in commentaries. The commentators, they would give explanations of why this works and so on and so forth. Okay. Anushka?
Yes, sir. So it's like not a way of like criticizing them or something,
I
but
know,
it's
I
like
know.
just so weird. Like they just give these random algorithms and there's absolutely no reason behind them. So like there's no reasoning about how you go to this step and why this works and stuff. So that was really fascinating. So
So
that was
one thing that we were discussing last week is that today the only means of knowledge for us, only way to arrive at some results is the process of deduction, right? We deduce this is true, or we see some result, we try to trace it back, say that, oh, where did it begin? A question that I need to think is that the only way to know? Is that the only way to gain knowledge, or could there be other ways to gain knowledge? I'm not saying that there is. I'm saying we don't know. So when they arrive at all these things, I'm not saying that somebody sat under a banyan tree, meditated for 10 years, and then they came out with a particular result. I'm not saying something like that. But sometimes you may not really think about other ways of knowing, which is not necessarily deduction. Just to give one example of Ramanujan, let us see. How Ramanujan got the ideas is something that he could not explain. Why? Because we don't know how to get the ideas in the way he is getting it. He also did not have a language to explain. Does it mean that he went only through deduction? We don't know. If that was the case, then he should have been able to explain that this is how I'm deducing, right? So similar. Anyways, this is more of a philosophical discussion. So I'll just move on. And is this process a little clear? I'm sure it may not be that trivial, or it's not trivial at all, that what is the logic that goes behind this. But are you able to make a connection between Nashta and Uddishta?
Yes, sir.
GL 1, 2, 3, 5, 8, 13. G is split as 2 L's, right? 2L, you write 1, 2, right? So that 2L becomes a G. See? So between Nashta and Uddishta, you should be able to see a connection. And then maybe something more may reveal. Janvi?
So which L's do you group together again to get a G?
The L, okay. So if you take the first example, we are subtracting 7, the row number, from 13, we get a result. From that result, you subtract the maximum number possible in this sequence. So from 6, you can subtract only 5. So 5 is the maximum. So you subtract 5 and this becomes a bold. You get the result 1. From 1, you subtract again 1, 2, 3, 4. What is the maximum number that you can subtract? You can subtract 1. So 1 and 5 become bold, and then you combine with their successor. Okay. Did that answer it?
Yes,
yeah.
thank you, sir.
Okay. Right. So we have a lot of things to think about. How did Nashta process come? How did Uddishta process come? What came first? What led to the other, and so on. But we'll leave that at suspense for now, because we have, I think, one more session, and I want to take you through the music part as well. So it's sometimes good to go just with some kind of wonder, not knowing how things are working, and you have a lot of time in your hand, until you come for RAMTP next year, that you can find out reasons why this is working. So this is what we call as the Virahanka numbers, or the Virahanka sequence or the Fibonacci sequence. Of course, Virahanka did not talk about this. He did not talk about this. He was talking about the pattern in poetry. Yes, Anushka?
So wherever we observe like something discovered by some foreigner, we see that centuries earlier the Indians had already done it, but still we give the name of foreigner only to that result or something.
Right. So I'll partially agree to this. I'll put a comment. So it's not that everything in mathematics that exists today existed in India, but a lot of things that exist in mathematics have wrong contributions, or they have been contributed to the wrong person. So there is a quote by a historian who says, if you find somebody's name associated to anything related to, say, a property or a theorem, it is very likely that that person had nothing to do with that. For example, you may have heard about the Pell's equation.
Yeah.
Pell's equation. A research session also you may have seen Pell's equation. Now Pell actually had nothing to do with that equation.
It's just Euler said it was Pell's equation.
Yeah. So Euler read this Wallace, in cursive writing, something he felt this is Pell, double L. So he thought that work was done by Pell, and nobody dare question somebody like Euler. So Euler says Pell, everybody starts calling Pell, and Pell has nothing to do with that equation. So
Euler says Wilson's theorem, but it is not Wilson's theorem.
Right. All right. So we have something called as Matra Meru. Meru is, again, Meru means a mountain. So like our Varna Meru, there is a Matra Meru. Matra Meru is something like this. What is this? S of 1, S of 2, S of 3, S of 4, S of 5, S of 6, S of 7, S of 8, S of 9, S of 10, S of 11, S of 12, S of... What do you think do these columns represent? Any clue? For example, what does this represent?
So is it like
Wait, do a raise hand. Do a raise hand. What does this represent? Harini?
Sir, I'm not sure exactly what the numbers themselves, but I realize that. So the first column is only ones, the second column is 1, 2, 3, 4, like that, the natural numbers. The third column is the triangular numbers. The fourth one is the I think square numbers is what they are called. So I think
Sum of triangular numbers. Sum of first and triangular numbers. Yeah. Okay, good. So the columns are definitely there, and maybe you see a knight's move jump, for the first position. Okay, all right. Anushka Tonapi?
So that's what I wanted to say. Like each column represents it each represents different n-gon numbers. So this one represents triangular numbers. The next one represents quadrilateral numbers, if that's what they're called. I'm not sure. And the next one represents.
We can name it. Who cares, right? Names are
Rectangular numbers.
Yeah, rectangular numbers. The next one does for pentagonal numbers, and so on.
Okay.
So they're basically polygonal numbers.
So it's just the Pascal's triangle or Varna Meru.
Sorry, say that again.
So it's just the Pascal's triangle. Same thing. Short
He's saying it's nothing but it's the Varna Meru, and he sees the Varna Meru here. Are you able to see the Varna Meru here?
Yeah.
Yes, sir.
You tilt your head. Right? This is 1, 2, 1. This is 1, 3, 3, 1, and this is 1, 4, 6, 4, 1. Right? It's the Varna Meru. Very nice. What else? Anybody else? Arjun. Arjun, do a raise and others.
So I was gonna say the same thing.
I see. Arushi?
Sir, just a question. I thought in the Varnamiru, the sum of every goes like 2 power n, but here it's Fibonacci. Why is that happening?
So in that Varnamiru, if you tilt it, you see this Matra Meru in that. You have a slight squint, if you do that, then you will see this Matra Meru coming over there. Because it is just a different way of rearranging these numbers, right? These sequences. In Varnamiru, we are arranging in a particular way. In Matra Meru, we are arranging in a different way.
Okay, I understand that, sir, but then why do the sums change? Are the rows
why are the rows adding up to 1, 2, 3, 5, 8, 12, 13
Yeah.
and so on?
Yes.
Is that
Yeah.
right? So to understand that, somebody will have to answer my question. What does this 3 represent and what does this 10 represent?
So why specifically 3 and 10?
You want to pick 5? I'll pick 5. I just picked 2 things.
I mean, represent as in what? I mean, like, with what context?
For example, if you take 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. If I ask you what does this 3 represent, you will say that
Okay.
represents 3C1.
Right.
But that may not be the case of this 3, just because you see a 3, right? Ritin.
Sir, the numbers are just increasing. For example, in the third row, the first number is 1. The second row, the first number is 1. And the third row, the second number is 3.
Mm.
In the second row, the sum of the first 2 numbers is 3.
Mm.
In the third row, the third number is 6. The second row, the sum of the first 3 numbers is 6. So the sums are adding up. This continues for all the rows.
Okay. Do you guys see something? I just wrote something.
Oh, yeah. So this is like the 4th one, right? The 4 Matra Prastha.
Yes.
Yeah, and it has 1, 3, 1.
So I ask again, what does the 3 represent?
The number of combinations which have both G's and L's.
No.
I think it's the number.
The number of rows which have
Three
three letters. I mean that.
So number of combination. So is it like for 3 syllable? This is like how much is it?
No.
So isn't it the number of?
So here, when we have
Arjun, followed by Anushka.
Sir, isn't it like the 1, 3, 1 means 1 with 2 letters, 3 with 3 letters, and 1 with 4 letters?
Close, but not correct. Anushka.
Sir, what? So you have written this for 5. So like when we have 4 matras, so we get 5 numbers, out of which 3 have like 3 letters. 1 has 2 letters, and 1 has 4 letters. And then when we go ahead, when we have 8, so I guess it's something like that number of letters in per combination. In the combinations we get, so it's 3 plus 4 plus 1, like that.
Okay, let me write down 8. Okay, that is LGG, right? You have this LLG, LLGG, and then we have LGL, and then this is L, and you have a LLG 4 and 1 5, LLLG, and you have a LLLL. Okay. Now these two, this one, these
3
will contribute to the 3
letters.
This and this
will contribute to the
contributes
4.
to 4.
And the LLLL will contribute to the 1.
1, yeah.
Contribute to 1.
Yes, sir.
So this one is the number of combinations with 0 Gs.
Yeah, 0 Gs.
Can I say that? It is all else.
Yeah.
All else. The next one is the case with anybody?
0 else.
I think 1G.
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 Yeah.
1G. Right? 1G. Next one is 2Gs.
2Gs.
Next one is 3Gs. 4G.
4G, 5G, and
5G.
6G.
See that? That's where the table is coming from. Okay. Today, go to your puja room, write Viranka and do a namaskar. All right. Okay. So that's Matra Meru. This is what we see. 3Gs, 2Gs, how many cases are there? 1G and these many cases. So this is our listing, right, for 6 Matra Prastara. And we get this. So basically, we generalize. If there are a number of gurus and the number of n Matra Prastara, then what will be the number of laghus and so on. Okay. So this is elementary algebra. So I'm not spending time here. We kind of move ahead. So this from the PPT, I mean, of course, if you need to understand this, you should know what is n choose are and so on, which I presume some of you would have been introduced, some of you may not. So then you look at all these things, it will start making sense to you when you take some time to make observations here. Okay. All right. So this is about the Matra Prastara. Let me see, what time is it? 1, 2. I have about 45 minutes, right?
Yes, sir.
45 minutes. So let's get into action to the music part. Okay. Now I know that we are going a little fast. We are not taking time for solving problems. Okay. And I'm doing that way this time because every time when I do this topic, I'm not able to expose students to the music part, which comes towards the end, because we keep solving problems and then we end up taking a lot of time for that. So maybe there are certain parts where you'll have to do some more practice, but I'm sure you guys will do it after looking at the PPT. So let's look at the math and music part. So here we see somebody named as Sharangadeva, who was a Kashmiri scholar around 13th century. He lived and he wrote a book called Sangeeta Ratnakara. In Sangeeta Ratnakara, he is talking about a lot of things related to permutations, combinations in music and beats and so on. So there is something called as Stana Prastara and Tala Prastara. So Tala is beats and Tana is what you have with swaras. Sa, re, ga, ma, swaras. So when we have an enumeration or a listing of swaras, it is called Tana Prastara. And if you have a listing of talas, then beats, you have a Tala Prastara. So talas are what we typically use in percussion instruments, right? Like tabla, mridangam, of course, classical percussion instruments. Okay. And in that, we again deal with problems like prastara, sankhya, nashta, uddishta. And then some meru. And like our Virahanka sequence, there is some other sequence called Sharangadeva sequence. Similarly, over here, so there is something called as Laghu Meru and so on. Okay, I don't know whether we will reach until there, but let's see. So Sharangadeva's text, Sangeeta Ratnakara, is one of the celebrated texts on music. So he was a Kashmiri Brahmin by origin, and Sangeeta Ratnakara is a complete treatise like Bharata Muni's Natya Shastra. and it has chapters on Swaradhyaya dealing with swaras, Ragadhyaya dealing with different ragas, and Tala, different compositions, and Nartana. Nartana is dance. So he didn't leave anything for anybody else. He said, let me just, finish everything. And two famous commentaries that are available today on Sangeeta Ratnakara is one is written by Kallinatha and the another is written by somebody named Simha Bhopala, which is again long ago. Okay. So Tana Prastara. If you have Sare Gama Pa, it's called a Tana. Rendering a Tana in a different order than the natural order is called Kuta Tana. These are just technical definitions. So if you have Sare Maga, it's a Kuta Tana. Okay, because it is not in the natural order, because Ma comes after Ga. In Tana Prastara, Sharangadeva considers permutations of Tanas of subsets of 7 basic musical notes, which we denote as Sa, Re, Ga, Ma, Pa, Dha, Ni, and that's it. The Sankhya, or the total number of rows in the Prastara, is the factorial of the number of elements in the Tana. What does that mean? If you have a 4 Tana Prastara, the question is, in how many ways can you rearrange them? And you can rearrange them in 4 factorial ways, or 4 into 2, 3 into 2 into 1 ways. If you have 5 swaras, then you can rearrange them in 5 factorial ways. So that is what the Sankhya, or the total number of rows in the Prastara, is the factorial of the number of elements in the Tana. Okay. Everything okay? You can just nod your head if it is fine and you have got it so far. All right. Now this is one of the most famous texts called Art of Computer Programming, written by Donald Knuth, and he dedicates 2 sections in one of his volumes on permutations and combination generation. It's not permutation and combination, but generating all the combinations. How do you generate them? And one of the oldest foolproof algorithms is dedicated to Sharangadeva for permutation and combination generation. And Sharangadeva does this in 3 lines. Tak, tak, tak. 1, 2, 3. Okay. Meera, question?
Sir, what is foolproof?
Foolproof means without any mistake or without any bug. No? Perfectly. Something like that. Yeah. Okay. So this is the rule for listing Tanas. Now I would want you to take a deep breath. We will not read through this. This is just for your reference. But let me go to my notepad and I'll try to demonstrate it with something. Okay. So our goal is to generate a Prastara of say 3 swaras. We'll start with 3 swaras. So 3 swaras, let's say Sa, Re and Ga. How many different possible arrangements are there? We know there are 6 possible arrangements. The question is, how do we list it down? Let me ask somebody, can you give me a logical way to list this? Pratyusha, can you give me a way to list all the possible combinations?
I don't have any algorithm or logic something like that.
How would you list it?
First, I would keep Sa, Re at the beginning and at the end. I mean, Sa, Re, no sir, Sa, Re will write first. So the first one is Ga we have written, and then we will write Ga at the first and Sa, Re at the last.
Ga, Sa, Re, like this.
Yes, sir.
And then?
Then we'll bring Re to the beginning.
Ga, Sa.
And then Re, Sa, Ga.
Or Re, Sa, Ga.
Yeah, both we can write. Re, Sa, Ga and Re, Ga, Sa we will write, and then we'll bring back to the beginning.
Okay. All right. So you have an idea and then you are taking it ahead, right? So if it is based out of some algorithm, we can ensure that we are not missing out something. Okay. So this is the algorithm that Sharangadeva gives us. And I want you to pay attention. Don't write anything down. Just try to understand. Again, the first step is scan from the left. Okay, scan from the left. But before that, you need to write Sariga in the natural sequence from left to right. Okay, scan from the left. When you see a pair in ascending order. In fact, when you see the first pair in ascending order. So in this case, Sar A is in ascending order. You see the first pair. Okay. Sar A is in ascending order. This is the first pair. Below the greater one, write the maximum possible smaller swara. What do I mean? Suppose you are having Re Ga. What you do is below Ga, what is less than Ga, Sa and Re? You write the maximum possible swara that you can write. I mean, greatest of highest value. So that will be Re. So below Ga, you will write Re. If you can use Re. Okay. So you below Re, now you write Sa. Copy down whatever is there on the right side. No problem. Now you have empty spaces to the left. Empty spaces to the left, write the rest in ascending order. Now you have only Re. So you write Re as it is. Again, scan from the left. When you see the first pair, which is in ascending order. So here it will be Sa Ga, ascending order. Below Ga, you write the maximum possible value that you can write, which is less than Ga, and that is Re. So what is left is Sa and Ga. Write them in the ascending order. Scan from the left. When you see the first pair in ascending order, below that, write the maximum possible value that you can write. So technically it is Re. Copy down whatever is there on the right side. So see, oh, there is a problem now because both places will have to have Re. So there is a small change here. Says write down the highest possible swara below this after taking a look at the right side. Okay. So right side you need to copy down as it is. So Re is definitely going to come, which means Re cannot come here. So the maximum possible is Sa. Now you place Ga to the left. Scan from the left. See the first sequence in ascending order. Below the greater one, write the one that is lesser than Re. See, we have Ga and Sa, but it has to be lesser than Re and the maximum value that you can, which is Sa. What is left is Re and Ga. So Re and Ga in the ascending order. Scan from the left. Re and Ga is the first. Below Ga, you write Re. Copy down Sa. And then Ga. Scan from the left. What do you see? I hope everybody is awake. What do you see? When you scan from the left, what do you see?
It is just the natural version of the first one.
Exactly. There is nothing of the ascending order. It is descending order, which means end of story. Process ends when the swaras are in descending order or when there is no ascending order.
So can you read about what you said about the right side, looking at the right side and then
Yes. So I was referring to which one? I was referring to this one. Sagari. Yes.
Sir, could you just repeat what you said? I got logged out accidentally.
Which part you heard?
No, sir. Could you just explain the fourth part again, the fourth point?
So the fourth point is the process ends when there is no ascending order in the sequence. Garesa, descending.
Okay, sir.
So point number 2 says when you see a pair in ascending order, you need to do something. But when there is no such pair, then the process ends. Coming to this question that somebody asked just now about this. Sagare. Saga is in ascending order. Below Ga, you need to write the maximum value possible. So below Ga, you have a Re and Sa. But if you write Re here, the problem is you have to copy down whatever is there on the right side. So you'll have a double Re. That is not allowed. So when you're copying down, have a look on the right side and see what is getting copied down on the right side. So if it is Re, then this is out of question and you have only one option left, Sa, which is less than Ga. Okay.
Thank you.
So what I want you guys to do is I want you guys to try Saregama. Saregama is going to give you 24. Okay, 24. I think we can create some breakout room for that. Maybe we have what, 37 people, maybe 6 breakout rooms with 6 people each. Volunteers, can you help me with that? Just open the breakout rooms and I'll take questions. Yes, Swasti?
I have a question.
So
what if we want to make a prastara with 5 swaras and
5 swaras.
Yeah, and we start with Sa, Ga, Pa, Re, Ma.
No, you have to start in the ascending order.
Oh, okay.
Yeah.
Okay.
Tanish?
Yes, sir. I just wanted to tell you that this Zoom meeting doesn't have the breakout room feature.
You are kidding me. Oh, all right. Have it looked into after this session. Maybe in the settings, there might be an option to do that. Take a look into it. So meanwhile, all of you start with the suffering. Saregama, how will you list it down? Meanwhile, let me take questions. Dhwani, you have a question?
Sir, I just have another algorithm for listing down the 3 swara prastara.
Yes, I'm sure. So this is just, one thing that I would want you all to keep in mind. We may come up with a lot of algorithms, right? There is this and we can do this, and they all can be amazing algorithms. But keep in mind that what is special about these algorithms is not just that they give you the list, but you have a method to find out which pattern will appear in which row. If you give a row number, what will be the pattern there? So if you come up with an algorithm, also try to see if you can have rules for Nashta and Uddishta processes. Then it becomes a complete package. You see, Dhwani?
Yes, sir.
I'm not trying to undermine what you're saying. What you might have seen or observed or come up with might be a very good algorithm. But the beauty of these algorithms is that it's not just Prastara. It is also about Nashta and Uddishta. That's where they get that $1 million prize. Anand.
Sir, in the Prastara, I didn't get the second to third step, I think. Could you, yeah.
Yes.
Yeah, second to third, I think.
This
So
one?
yeah. So
Go ahead.
Sa and Ga are ascending. So
Yes.
we took Ga and we made that Re. And then on the left, what is going on?
After you write Re, you see on the right side if there is anything that you can copy down. Clearly, there is nothing to copy down. So there you see on the left, are there empty spaces? Yes, there are empty spaces. Whatever is left, you write in the ascending order.
Okay. Okay, got it.
Anushka, any question or you forgot to lower your?
No, sir, as Vani said about an algorithm, like when we first keep the first set of fixed and permute the rest, and then continue that way. Wouldn't that be much easier?
See, like I said, the idea is not just to list. You want Nashta and Uddishta processes also here. So in the listing that we have, how do we find the row number of a given arrangement? How do we find what arrangement will come in a particular row number? Our algorithm should be able to encompass all these things. Right?
Okay.
Yeah. Janvi?
Yeah, so sir, this prastara is only for like three syllables, like sa, re, ga. Now you have,
No, sa, re, ga, ma.
Sorry, sir. No, I'm talking about the third one. Yeah, so for this, but there are 7 swaras, so won't we have to choose R or something, because we'll have permutation and combination if we want to do 7 swaras in 3 different, only in 3 positions.
So I just used sa, re, ga. You can use sa, re, ma. You can use re, ga, pa. You can use anything.
No, like what if I were to use all the 7 swaras and but only 3 positions?
Oh, that way.
Yeah. So is there a prasthana for that?
Welcome to be the next Sharangdeva. Devanand.
Sir, can you please explain this process once again?
From which part you want me to explain?
Sir, I didn't get. First, we found the pair which is in ascending order. That is S and R in the first step. Then which letter should we write below R?
Below R, see this is sa is less than re is less than ga is less than ma. Okay. Now we are writing below re. You are seeing what are the options that you have below re? You have only sa. But suppose the question is, suppose it is sa, ma, re, ga. Okay. You find the first ascending order, or maybe, let's say ma, ma, ga, or ma, re. Just one second, ma, re, sa, ga. Okay. So ma, re is not ascending. Re, sa is not ascending. Sa, ga is ascending. So below ga, you check what among sa, re and ma, what are the letters that are less than ga? So it is sa and re. What is the maximum that you can use below ga? You can use re. I mean, re is the closest to ga. So you write re over there. And now what is left is sa, ga, ma. Sa, ga, ma. Write that in the ascending order on the left side.
Okay.
So below in the from the first step, what you do is below re, you write sa, copy down whatever is there on the right side. To the empty space, you write re. Anushka?
Yes, so I was doing the for the 4 sa, re, ga, ma. So I got something like sa, ga, ma, re, S, G, M, R. So
Okay. Sa, re, ga, ma, and then what is the next one?
Yeah, then I got re, sa, ga, ma, R, S,
Okay, let me go slow. So this is Shruti, I think there is a background. Yeah. So below re, you write the maximum possible value, that is sa. copy down whatever is there on the right side. In the empty spaces, write the remaining in the ascending order. Then you scan from the left, find the first pair that is in ascending order, which is Sa and Ga. Below Ga, you write the maximum possible value that is less than Ga, which is Re. Copy down whatever is there on the right side. What is left is Sa and Ga. Write this in the ascending order.
Yes, so after this, I have problem. Like the R is repeating.
Where? Oh, yeah. I see now. So now you scan from the left. When you see the first ascending order below Ga, you need to write the maximum possible value, which is Re. But if you do that, then Re is going to repeat. We don't want that to happen. So what we do is, we should be able to copy down whatever is there on the right side. So what we do is, below Sa, whatever is left, what is left? Sa and Ga. What is the maximum? I think I said below Sa, I meant below Ga. So below Ga, I write the maximum possibility, that is Sa, and I write Ga. So Ga, Sa, Re, Ma. Can you scan from the left, Mrudula?
Sir, it isn't a doubt. I raised it for this thing. I completed.
Yay! Did you get 24?
Yes, sir. I got 24.
You counted, huh?
Yes, sir. I've written the serial numbers for each.
Okay. Good. So can I see a show of hands by people who have completed, so I know whether I can proceed or... Mrudula, are you a student of music?
Yes, sir.
Yes. Okay. Pratusha,
Completed, sir.
Completed.
are you also a student of music?
Yes, sir.
Yes. Okay. Dhwani,
Not
Miss,
says.
Done, sir.
Sir, I completed.
are you a student of music, Dhwani?
Yes, sir.
I see.
Sir, I
Simran,
completed too.
Yes, sir.
are you also a student of music?
Yes, sir.
What music do you learn?
So, all music, but main focus on classical music.
Hindustani or Carnatic?
The Carnatic music.
Carnatic. I see. Anushka Tonapi,
Yes, sir, I completed it.
student of music.
Sir, 6 years, sir.
Krutika,
Yes, sir.
student of music.
Yes.
Which classical, Carnatic,
Yeah,
Hindustani?
classical and instruments. I play a lot of instruments.
Shresht,
Yeah.
yes for both questions.
Yeah.
Advait,
I'm done and I'm not a music student.
so
Finally.
right. So finally, we see a mortal. Yeah. But
I
you
was starting
see,
to feel that I was the only student of dance here.
sorry, who is that?
No, sir, Anushka here. I am a Bharatanatyam dancer, so I was starting to feel that I'm the only dance student here.
Right? But you can see, students of music are able to get it more intuitively, perhaps, right? So I often feel that we should introduce these topics of permutations and combinations to students of music through music, not by in how many ways can you arrange A, B, C, D in a row.
Yeah.
All right. Okay. Hands down. How many of you want me to do it on the, on the board? I'll do it.
Sir, it'll take a whole lot of time for writing 24.
It's all right. Who's in a hurry?
Can you just say what you have to do after GSR?
After GSR.
GSR, I made a mistake.
Gasarema. Okay. Now, the first pair in ascending order is Sare, right? Sirinandan? below re, you write the maximum possible value, which is sa. Copy down whatever is there on the right side. You are left with re, ga. Write it in the natural order.
So what exactly do you mean by a maximum possible value?
Sa is less than re is less than ga is less than ma.
Yes, sir.
Now below re, whatever is there, suppose it was ma, not re, or maybe it was ga, let us say. So below ga, we want to write something. We have to write amongst whatever is lesser than ga, what is the maximum that you can afford to put there.
Okay, sir. Got it.
So Srinandan, give me the next row.
So next, R and G are in an ascending order.
Re and ga.
Re and ga are in an ascending order. And then under ga, the maximum we can write is ra.
Re.
And then we just write down SM. I mean sa.
Sama.
Sama. And under the first one, re, we just write ga.
Right. Kirti, give me the next line.
Yes, sir. So below the below ma, it has to be sa.
Why?
Sorry, ga.
Why?
Because ga is the small, largest, smaller.
Yeah, largest among whatever is smaller than ma.
Yeah.
Right. So you write a ga.
And then sarima.
Sarima. Right, and slowly you start. This is then below ma. What do you do? Let me ask somebody. Whom should I ask? Ishan.
Sir, a comment.
1 second, Ishan. Go ahead.
So the highest smallest is R. So you write R.
No, where?
Below M.
Below ma. Why not ga?
Because ga is to the right. And
we need to copy down as it is, right?
Yeah.
So re. Then?
Yeah, and then the rest, the S and the so and ma, you have to write them ascending.
All right. Listen, and this goes on, right? Okay, good. Yes, Mrudula, question or comment?
Comment, sir. Sir, in this order, when we look closely, the first sits end with ma, the next sits end with ga, the next sits end with re, and the next sits end with sa.
Arushi, what is Mrudula talking about?
She's saying like that first it ends with M more for a long time, then it ends with go for a long time, and then it ends with ro, and then sa.
Right. This right
ends with
1/4 of the time.
Yeah. Can I add?
Yes.
The last two rows are GM, GM, RM, RM, SM, SM, and then they're like the same of the two repeated. In the first two, whatever pair is in the first line, the second line is the same one but reversed. Like SR, RS, SG, GS.
And then the one missing is like doubled in both of them. For example, Sir, Re and Re, Sir, and G is not there. So it's there, like in the next row, next column.
There's a pattern amongst the columns.
Yes.
Yeah.
Sir, that was part of my algorithm that I was about to say last time.
Okay. So if any of you saw this pattern and saw that, okay, for 6 mas, 6 gas, and 6 re's and 6 sas, then how do we do? Okay, I have a ga ga re re sa sa mama re re sa sa. Then you see a pattern mama ga ga sa sa mama ga ga re re. You say re sa ga sa ga re. Re sa ma sa ma re. Some patterns you see. For seeing patterns, we may not
sir.
have.
The first two rows patterns are more obvious combining both of them, Sari and then Risa.
Right. Simran?
So I had just observed that the prastara we did with 3 swaras and writing them same 4 times and adding 6 ma in front of them, 6 ma 6 girls, and we'll get the.
So what Simran is saying is, look,
Just like Pingala's algorithm.
Take this thing, and this is nothing but what we had seen here. Sorry. Yeah. For the, oops. Yeah. Sheesh. Sorry. Okay, never mind. My OneNote is a little stuck. So this thing that you have, she's saying copy and paste it here. Put mas at the end. Replace the ga with ma. Do a Control F and replace all ga with ma. Paste it here. What you replaced, ma with, or what ma replaced, you put ga. Again, copy and paste. And then read. See, one idea, it goes such a long way. 300 BCE to 1300 CE. 1600 years. It's the same idea. You're just tweaking it a little bit. Right? And you get this. Okay. All right. So I want you to look at this order. So there is something called as lexicographic order, reverse lexicographic order, mirror image of reverse lexicographic order, and mirror image of lexicographic order. Okay. So these are different ways of sorting, basically. One is you write the first way of sorting. Can somebody tell me what is this first way of sorting?
Sir, it is ascending.
It is ascending order, as simple as that, right? Next one, reverse lexicographic order.
That is descending.
Descending. Mirror image of reverse lexicographic order.
The mirror image of that.
Mirror image of this, right? Now, in the listing that you have of Sarega, Saregama, is one of these being followed?
So it's basically the same thing, like in lexicographic order, you take
mirror image.
I think it's the mirror image of the
Mirror
reverse.
image.
Mirror image of
Yes.
Mirror image of the reverse lex.
yeah, the mirror image of reverse lexicography.
Right? Right? So it's so what we are following is this order, the mirror image of reverse lexicographic order, which means if you assign values as 1, 2, 3, 4 to Saregama, and then sort it in the descending order and take its mirror image, you will get the order that we are following here. If you ask, why should we do that? Can't we just sort it in the alphabetical order, or maybe in the ascending order or descending order? Yes, you can do that. But by doing this, they didn't have to change the algorithm much. When I'm saying change the algorithm, I'm talking about Pingala's algorithm, then Virahanka's algorithm. The same idea could be continued, and you can use the existing method of Nashta Uddishta and tweak it a little bit. Okay. Is this enough, or should we proceed? If it's an overdose, we can take a pause. Looks like an overdose, huh? How much time do I have, volunteers?
10.
10 minutes.
10 minutes. Okay, let me see what lies in store. Okay, Khandamir will go later. So this is the Meru that we are going to see next, the factorial Meru. This is like the Varna Meru, the Matra Meru. In Khandameru, or Khandameru is what you can use to find if you have something like Sa, Re, Gama is in which row, Re, Ma, Ga, Sa is in which row, using that algorithm. So we can use Khandameru to do that. Questions, classes, what is that? I didn't realize 10 minutes left. Thank you. I take that as a compliment. Next is, can we have negative factorials? Negative factorials, it seems, yes. In fact, there are also fractional factorials and stuff like that. So I'll tell you a fun fact. I was attending a talk by the founder of a program called PROMIS, PROMYS. Some of you may have heard of this camp called PROMIS, PROMYS. It's a camp mainly on number theory and other areas in mathematics that happens in Boston. And there is also a PROMIS India chapter. So PROMIS India is a fully funded program. So the founder of PROMIS, or the director of PROMIS Boston, he was in IISER Pune, IISER Pune, along with one of his colleagues, and he was doing some kind of a demonstration talking about PROMIS, and he wanted to do some math also in that. And he took topics from history of Indian mathematics. Okay, he spoke certain things from Leelavati and certain things from this, Chandas, Meru and all that. And he was like, no, because all of you are from India, I'm sure that all of you would be knowing what I'm talking about. And that was a big silence in the crowd. When I was looking here and there, and mostly they were all faculty and students from IISER Pune, but there was hardly anybody who was exposed to all this. For some reason, I felt I was the most knowledgeable person there. Because in a place like IISER, the faculty are extremely qualified. The students are also very high potential. But I could see that how much disconnected we all are. I mean, not to blame anybody, but we all are from the history of, from our own literature of what existed in India. And then there is a American who's coming and saying, I'm sure you all know all these things. So he knows about all these ideas. And from there, he introduced fractional factorial and how that works and so on. So it's a lot of interesting stuff.
Interesting and embarrassing.
But the good thing is that as 13-14-year-olds, now you know so many things about Indian mathematics, right? It's not so. When it comes to history of math, it's not just something about, okay, we are trying to say that India was great in the past and those kind of things. I mean, it was to a great extent, but then what I feel, I feel the most is there were so many amazing ideas which we can use even today, right? And those ideas we are missing out. We are losing that because we are not getting exposed to these things. And that is what I feel pain about the most. When we are learning modern day mathematics, we see, all these things, those who are in a bit of introduced to a bit of programming, you can see that these are all programmable things. We are getting all these algorithms for free. You write a program, and these are all mathematical problems. Like I was so happy to see Arushi thinking about those problems. Look, that f of n and f of n-1, n-2, they looked very similar to this particular problem. The problems that we were discussing. So there are so many further math problems that we can explore. In fact, we did not even touch about why the Nashta process works, why the Uddishta process works, or why all those processes work. I think these are all problems that you can take back and you can think about it. You can work on them over a period of time, see what results you can come up with. And you will feel so happy that I was able to understand what they did. You see, the happiness that we experience, if you remember Hari sir session on Varga Prakriti, there were about 8 students in that batch, and Hari sir closed in a room for 7 days. Not literally, but that's how they would be usually. And they are just thinking, how did this come? Where did he or she get the idea? And they were trying to trace back, and at some point they even came up with an idea which was just amazing. Okay, so one day, they all celebrated, like, wow, this is a great observation that we made and proved. Next day they find out that Euler had already discovered that. Okay, so Euler leaves nothing for anybody. He said, I'm going to finish off everything. That was his style. And then they were kind of heartbroken that Euler kuch to chhod dete to acha hota. In Hindi, if you say, he should have left something for us. Why did we have to discover all these things? But then on the second thought, we were feeling, oh, these guys, 10th and 11th graders, they found out what Euler had discovered. But that's so amazing, right? Now, where did that come from? That came from deep thinking and sitting and breaking your head on one problem for a lot of time. And of course, those guys, they had multiple skill sets. So one of them was very good in pattern. He would always think, how did he come up with this particular thing? And there was somebody else who think, why does this work? And these two combinations are amazing combinations, because one can see the pattern or something intuitive about, oh, where is this coming? The other person says, I have no idea where that comes from, but give it to me, I will prove it. Right? So amongst all of you also, it will be really great that even after the camp, you see that, if at least people who live within a city, right? And you see there are so many from Chennai, so many from Pune, Bangalore, all these cities, or from the same school. Sit with each other and see, take up one problem and see what you can explore further. Not for anybody else, but to get the joy of finding out how people in the past thought and where did they come, to satisfy that question that Anushka Tonapi asked, where is this coming from? All right. So I think on that note, we can take a pause. But in the next session, I want you to have, enough food and energy and tried something on this, because over there, we are going to move from music to Tala.